I've had a number of requests about long division and questions that involve unfeasibly difficult type of questions. Here we've got an example of 34.56 divided by 2.457. Now why anyone would want to do that without a calculator, I'm not quite sure. But if you did, then I'm going to go through the kind of things that you could do to make it easier for yourself. The first thing I do is try and remove these decimal places, particularly the decimal places at the bottom. I don't like dividing by a decimal, and what I'm going to do is I'm going to multiply by 10 or 100 or possibly even 1,000 to remove the decimal places. For example, we can all see that 10 divided by 5 is exactly the same as 100 divided by 50. I've made it 10 times bigger in both cases. The answer to this is exactly the same as the answer to this. So if I had a question like 14.5 divided by 0.3, then again I could make that easier for myself by multiplying the top and the bottom number by 10. Here we get 145 divided by 3, and you could have a go at doing 145 divided by 3, which will give you the same answer as 14.5 divided by 0.3. So if I was presented with this question, then the first thing I do is multiply by 1,000 to get rid of the decimal point, if you like, from this bottom number. If I multiply by 1,000, I would end up with 2457, and if I multiply the top by 1,000, I would end up with 34560. Okay. Now the answer to this question is exactly the same as the answer to this question, but I don't have to worry about any decimals, so this is the one that I'm going to have a go at. Now again, as I've said, it's an incredibly difficult question. Why you'd want to do this without a calculator, only probably some sadistic maths teacher would set this kind of question. But how would we go about it? Well, one of the first things I'd be looking for would to find out whether or not these two numbers now cancel. I've multiplied them by 1,000 in order to get the question. I'm treating it like a fraction, and I'm going to see if I can actually cancel these numbers. They clearly don't cancel by 10, they don't cancel by 5, neither of them are, both of them aren't even numbers, so I can't cancel by 2. Let's see if there are any other tricks. The only other trick I've got up my sleeve is to see whether or not the digits add up to a multiple of 3, because if they do, then I know they're going to cancel by 3. And in this particular case, 2 add 4 is 6, add 5 is 11, add 7 is 18, so that is going to cancel by 3. 3 and 4 is 7, add 5 is 12, plus 6 is also 18, so I can cancel by 3. And if I do that, what I'll end up with, 3's into 1, 3 go 1, 3's into 4 go 1, remainder 1, that gives me 15, so that's 5. I can cancel by 3, I've actually divided by 3 here. Again, if I divide by 3, that gives me 8 and 819. Better check that with the calculator that I'm not supposed to be using, but I believe what I've done there is divided both numbers by 3. So the answer to this is exactly the same as the answer to this, which in turn was the answer to my original question. And it's easier to divide by 819 than it would be if I was going to divide by 2457. Again, I could add up. This actually adds up to the digits add up to 9, the digits add up to 18, so again I can cancel by 3 again. 3's into 11 go 3, remainder 2, so that gives me 3 into 24, 8 times with 1 left over, and that gives me, I think, if I cancel by 3 that number, 3's into that go 2, remainder 2, so that'll be 7, 3. Again, I'm ending up with a question that is easier to work out than the one that I originally started with, by cancelling by numbers each time. But let's say you couldn't cancel this. Let's think of a question that we could have had that doesn't divide by the same number top and bottom. In which case, how would you go about a particularly difficult question. So I'm going to change these numbers around. I'm going to choose another couple of sets of numbers.